Hi there, this is Mr. Wolf. Welcome back for another edition of Geometry. Today we'll be doing benchmark 22. I can use properties of parallelograms, including diagonals, sides, and angles. Before we go any further, I do want to put a little advertisement out there. I want to create a intro for my videos. So if you've got ideas for music, video, if you're good with that kind of stuff, please let me know because I'm looking for some help to create a video intro for all of my geometry videos. As always, make sure you have some paper and pencil there to take some notes. And remember, you can pause at any time to write something down or rewind as needed. So let's get started here. First, let's talk about polygons and specifically quadrilaterals. So any polygon, remember from our previous benchmark that polygon means many-sided figure. Well, a polygon that has specifically four sides is called a quadrilateral. Okay, quad means four, lateral means sides, four sides. Okay, but within quadrilaterals, you're probably already aware that there are certain ones that have certain properties. And here's actually a nice diagram to explain how they're all related. I would suggest you pause here and copy this down. So let me explain. The big box, everything inside the box is a quadrilateral. So quadrilaterals include trapezoids, parallelograms, rectangles, squares, and rhombuses, or sometimes called rhombi. This thing over here is a quadrilateral, but you'll remember that this side right here is what we call concave, so this is just a concave quadrilateral. Trapezoid is over here, we'll get to that later. Really what we're concerned with are parallelograms, which means that opposite sides are parallel. And of course you're familiar with rectangles, squares, and maybe even rhombuses, and you'll notice that with each of these, they do have some properties that are similar. Each of them have opposite sides that are congruent and parallel. And I'm going to detail all these properties on the next coming pages. But for now, just make sure you get this Venn diagram drawn. A quadrilateral with two pairs of parallel sides is called a parallelogram. And to write the name of a parallelogram, you use this symbol right here. It's actually a small parallelogram. So in my example here, we're talking about parallelogram ABCD. Okay, we keep the letters in order, and we would call that parallelogram ABCD or the label parallelogram ABCD. And we know that AB is parallel to CD and BC is parallel to DA, and that's what makes it a parallelogram. Okay, but remember, under parallelogram you could have rectangles, you could have squares, and you could have rhombuses. So just because it's a parallelogram doesn't necessarily mean or doesn't really tell us exactly what kind it is. Okay. Let's go back to benchmark 4, where we have parallel lines and transversals. Here I've got two sets of parallel lines, and you can see the shape that is formed is actually a parallelogram. So if you can remember back to benchmark 4 or look at your notes, you're already going to know what a lot of the properties are. You already know that this angle equals this angle. You know that this angle equals this angle. All right, you know the sides are parallel and they're also congruent, and these would be parallel as well. And there's actually some other properties too involving the diagonals. Okay, and all those properties are written here. An easy way for you to organize all this information when you pause here in just a moment to write it down is look at these three categories we're in. We've got sides, we've got angles, and we've got diagonals. Okay, you'll need to pause and write all of this information down. I would suggest writing down the definition and make sure you add the picture, because for me the picture is actually easier to read than the definition. I can see this picture tells me that parallelograms have parallel sides, and this picture here tells me that parallelograms have congruent sides, so they're parallel and congruent. Okay, next with angles, this tells me that opposite angles are congruent, and this tells me that consecutive angles are supplementary. And you'll remember that from when we did our parallel lines and transversal, that consecutive angles were always supplementary. So this should be reviewed for you. Last, let's look at the diagonals. When we connect the opposite vertices, we see that when we connect the diagonals, they bisect each other. So that means they cut each other in half. That's why this half is congruent to this half, and this half is congruent to this half. Lastly, one diagonal forms two congruent triangles. All right, so this triangle here, I'll outline right there. That triangle is congruent to this triangle. So if we know the two triangles are congruent, then we know some of the angles are congruent, and we can find various lengths and angles. Okay, this is all looks similar, but this is the converse. And you guys remember from benchmark 6, converse means to just flip it. So whereas over here it says a parallelogram is a quadrilateral with both pairs of opposite sides parallel. Here we would say if both sides, both pairs of opposite sides are parallel, then it's a parallelogram. Okay, so the converse is just backwards. If we're trying to prove it's a parallelogram, just use the properties. All right, and here's a look at a parallelogram, and we can just check out some of the properties using our protractor here. So I'm going to put the center of my protractor on my vertex there. Okay. All right, I'm going to grab this and spin it so it lines up with 0. 0, 10, 20, 30, 40, 50, 60. Looks like it's right about 65, doesn't it? So let's write down 65 over here. And just to confirm, I'm going to slide this protractor across over to here. Okay, line it up. I'm going to rotate it. So the zero's on there. And we go 0, 10, 20, 30, 40, 50, 60. And it's just right about in between. 65 is correct. So indeed, opposite angles are congruent. Okay, let me get the protractor out of here. You can see, but we could measure if you wanted to. You can see that this side right here, BC, is congruent to AD. And you can see this side, AB, is congruent to this side. Okay, so opposite angles are congruent, opposite sides are congruent, opposite sides are parallel. Sorry about the sloppy writing, but it's hard to write with a mouse. The magic word for this particular quiz will be trumpet. So on the quiz, answer accordingly. All right, and we know the diagonals bisect each other. So this is equal to this, and this is equal to this. Really simple stuff. Just get it down in your notes, and we'll practice it in class. Okay, so here's sort of a summary of properties of parallelograms. If a figure is a parallelogram, then opposite sides are congruent. If a figure is a parallelogram, then opposite angles are congruent. If a figure is a parallelogram, then consecutive interior angles are supplementary. And if a figure is a parallelogram, then the diagonals bisect each other. So sometimes what we'll see is these properties used in the coordinate plane. So they might give you a point here, and a point here, and a point here. And they would ask, where would the fourth point go in order to make a parallelogram? Okay? Real simple. What you would do is figure out, well, what's this slope? Okay, this slope, it looks like the rise is 1, 2, 3, 4, 5, 6, 7, and the run is 2. So negative 2. So it'll be 7 over negative 2. So all I know, let me get rid of some of this. All I know is that this from here to here should be 7 over 2 as well. So I'm going to go 1, 2, 3, 4, 5, 6, 7 over 2. Boom. I know that my point has got to be right here. I'm going to do the same with this side. This side would be 1, 2, 1, 2, 3, 4. So let's go 1, 2, 1, 2, 3, 4. And definitely can see that my point, we'll make it real nice and obvious. My point is right there. All right, and we'll do some more practice with that as well. These are what you'll see problems looking like, okay? Like this, or like this, or this, or this. Let's just do one of these so we get an idea of what we're getting ourselves into. Let's try this one. This says in parallelogram CDEF, DE is 74, so I'm going to label that. Ooh, I don't like that. Let's get back to a normal pin in here. There we go. So this is 74. Okay. And it says DG, D to G is 31. Okay. And the measure of angle FCD So that's F to C to D. So this angle right here, that is 42. I'm going to write it right over the line so I know it includes both sides there. Find EFC. EFC. All right, so they're asking for this angle here. My first question would be, why did they tell me how long this is, how long this is, if they're asking me for an angle? And your answer would be, because they are testing us and trying to trick us. Yes, this is 74. Yes, this is 31. So this is 74. And this is 31. But that gets us nowhere closer to this angle. Okay? We can look at this angle and see they're not congruent. So if they're not congruent, what's the only other option? The only other option is that they add up to, you got it, 180. Consecutive angles are supplementary. So 42 plus our angle, which we'll just call x, equals 180. And you know to just subtract 42 from each side. And we figure out that angle x equals 138. Easy stuff here. All right. This problem looks similar, but now they're asking for side DF. Of course, if they told us that this section DG is 31, you know that that's bisected, so this has to be 31. Add them together, and you get DF, which would be 62. Right? There would be, let me go back there. You would not be able to solve this problem if you didn't already know that the diagonals were bisected. So that's why it's so important to make sure that you have down all of these properties, all these pictures here, and that you understand them. Okay? All right, so let's flip to the end here and summarize. First off, what is a quad? A quadrilateral is any four-sided figure. All right, but within those, we have parallelogram, we have squares, we have rhombuses, we have rectangles, kites, trapezoids, rhombuses, all kinds. Right now, we're focused on parallelograms. All right, so you need to make sure you know the properties of the sides. Opposite sides are congruent. All right, and parallel. Angles, opposite angles are congruent, and consecutive angles are supplementary. And finally, your diagonals bisect. Oh, that writing is horrible. I apologize. They bisect each other, so they cut each other in half. Okay, that wraps up this video lesson over benchmark 21. Make sure you took notes. If you're a little confused, there are some cool web resources. I found this one here, which is kind of neat. We can flip around and check out how a parallelogram changes and what doesn't change. And there's a lot of information here as well. Anytime you guys want to learn anything, just get on Google, Google the topic. A ton of stuff will come up. That's how I find a lot of the stuff to teach you guys. Of course, there's always Khan Academy. Come here and type in parallelograms. All right, and there's going to be something on them. This is area, opposite angles, opposite sides, so forth. So put a little bit of time in, and it'll pay off later. Mr. Woolf, signing off.